Mock paper 4, set 4. So we have the table. From the table, we can identify the type of the material. As you can see, the first one, high melting point, high boiling point, good conductivity in a solid and good conductivity in a liquid. So what we can say it is a metal. The second substance is having a low melting point, low boiling point, poor conductivity. So we can say it is a simple covalent compound. The third one, high melting point, high boiling point, does not conduct electricity in solid, but does conduct electricity in a molten or aqueous. So it's written in a liquid state. So what this give an indication? This give an indication it's an ionic compound. Low melting point, low boiling point, poor. So this also give an indication that is a simple covalent. High melting point, high boiling point does not conduct electricity in a solid or a liquid. So this give an idea it is a giant covalent compound. Because these are the characteristic of a giant covalent. Low melting point, low boiling point, conduct electricity in a solid, does not, conduct electricity in a solid, but can conduct electricity in a molten state. What this give an indication? A substance F. Yeah, but if you see a melting point is -5, yeah, it is liquid, but because usually the journal properties here it resemble with, because it does not conduct electricity in a solid but can conduct electricity in a molten or a liquid state. It means that these are the properties of ionic compound. But this is mismatch. Like this, when I say it's a mismatch, means these are the not properties of the ionic compound. So we have a metalloids as well. Metalloids means like they have substance for some properties resemble with the metal.
Sorry, what about the second exam? Second chemistry exam. I didn't see it. Also there.
Some resemble with the metal and some resemble with a non-metal. So you can use a screen annotation or a mic or a chat to answer. So which substance could be a metal here? So which substance could be a metal? So A could be a metal. State all substances, state all the substances that are liquid at room temperature. Room temperature, we will take 25. State of a substance before its melting point, it is solid. Between the melting and the boiling point, the substance is a liquid. And after the boiling point, the substance is a gas. So if we write 25, this will be solid. If we write 25, this will be a gas. If we write 25, this will be a solid. If we write 25, this will be a liquid. If you write 25, this will be a solid. And if you write 25, this will be a liquid. So D and F are the liquid at room temperature. Which substance could have a macromolecular structure similar to that of a silicon 4 oxide? To have a macromolecular structure, high melting and a boiling point.
So after this call, I want to ask you.
Okay, sure.
Because it faced me a lot.
You have question now?
Yeah, but after we finish.
Okay. Which substance could have a macromolecular high melting and boiling point? It does not conduct electricity in solid or a liquid state. Which substance could be a propane? Propane means simple. Propane is a gas at room temperature, first thing, and it is a simple molecular. So which substance is a gas here at room temperature? So B is a gas at room temperature, and the simple molecular structure, simple covalent structure, does not conduct electricity in molten or liquid state. Then which substance could be sodium chloride? Sodium chloride is an ionic compound. Ionic compounds have high melting and a boiling point usually, and they are not good conductor in a solid state, but can conduct electricity in a molten. So it matches or resemble with option C. C, because this is the C. If you have any question from paper 2, 4, or 6, you can send me on WhatsApp. I will try to discuss them during a session, and I'll begin next time session with your doubts specifically. It can be from paper 2, 4, or 6, any paper. If you have any doubt right now, you can send on WhatsApp. After discussion of this paper, I will discuss those doubts as well.
Sir, you want to change this paper?
No.
I solved it already.
Okay.
For 30 minutes.
Come here.
While coming to you, I solved this
Okay.
paper. That's why. So it's let's give you.
And do one thing, take this. Because that is what you need. So in this question, the table gives the composition of 3 particles. You can see 3 particles are there. Yeah, the question why which substance is a macromolecular? Macromolecular structure. To be a macromolecular structure, it should have high melting point and boiling point, and it should not conduct electricity in a solid state or in a molten state. That's why we selected E in that case. The question is particle A is an atom because it has same number of protons and electrons. That's why it's an atom. A, B, C are the particles of the same element.
Same thing, but same number of.
So how we can identify they are particles of the same element because they have the same number of proton. Proton is the identity of element. If any one of you did not receive your mock for chemistry, paper 4 mocks set 1, 2, 3, or 4, just let me know so I will send it because I have all of them are marked. Maybe if you did not receive is maybe I forgot to forward that. Okay. So chemistry, I'm talking about chemistry paper 4, mock 1, set 1, 2, 3, 4. If you did not receive any of them, just let me know. I will share that again with you. Particle A and C are the isotopes of the same element. So how they are isotopes of the same element? Because isotopes, because they have a same number of proton and electron, but they have different number of neutron. And use the term nucleus, like you will say same number of proton and different number of neutrons in the nucleus. The electronic structure of particle A. Particle A contain 16 protons, 15 protons, 16 neutron, and 15 electrons. So what is the configuration of atom? So 2, 8, 5. First shell 2 electrons, second shell 8, and the third shell 5. Element a metal or a non-metal, and give a reason of your choice. What is element A? It's a non-metal because it contains 5 electrons in the outermost shell. So it will have a tendency to gain good. So, or you can say it contains more than 3 electrons. Usually when 3 electrons are there, it is a metal. If more than 3 electrons, it will be a non-metal. So you can also, this is also a right answer. You can also state that it contains more than 3 electrons in the outer shell. Because metal atom should have more electron, like less than 3 electrons. 3 or less than 3. In question 3, the kinetic theory explains the properties of the matter in terms of arrangement of movement of molecules. Draw. No, you cannot say it's a non-metal because it's on the right-hand side of a periodic table. Why you cannot say that? Because you have the configuration. In the previous question, the configuration was given. So from configuration, we identify it has 5 or it has more than 3 electrons. So it should be a non-metal. You're not supposed to say it is on the right-hand side of a periodic table. Draw the electronic structure of a nitrogen molecule. So nitrogen belongs to group 5. Group 5 will share 3 electrons. So each nitrogen share 3 electron with another nitrogen and unshared will be 2. This is called a dot and cross diagram. Delivery tube.
Delivery tube.
Yeah.
Delivery tube.
Yeah. So why 2 marks? When you draw 3 pair of electrons, the shared between them, and 1 pair is like a pair of electron which is unshared. The next we have compare the movement and the arrangement of the molecule in a solid nitrogen to those in a nitrogen gas. if you compare the movement and arrangement of the molecule in a solid nitrogen and a nitrogen gas. So first, what about the movement in solid nitrogen? In solid nitrogen, particles are regularly arranged in which they can vibrate about fixed position. Whereas nitrogen gas, the particles will move randomly and no regular arrangement is there. And they move at a high speed. That's a good answer. A sealed container contains a nitrogen gas. The pressure of a gas is due to the molecules hitting the walls of the container. Use a kinetic theory explain why the pressure inside the container increases as the temperature increases. So what will happen? The particles gain kinetic energy, move faster, and hit the wall of the container often, or more often collisions are there, or hit at a higher speed or a greater force. That's why it increases the pressure. The following apparatus is used to measure the rate of a diffusion of the gases. The following results were obtained. You can see different gases are there. So nitrogen is there all at like 25, 25 and 50. The rate of a diffusion, 1 cm cube of a nitrogen move or diffuse every minute, but chlorine only 0.63 cm cube diffuse when nitrogen at a high temperature around 50, 1.05. Explain why the nitrogen gas diffuse faster than chlorine because less mass, particle size, no need to say a particle size, but it's of 2 marks. How you score the 2 marks? It is very important to use the term relative atomic mass or relative molecular mass because it's a relative molecular mass. It's a mass of a molecule compared with a carbon atom. So you will say it has a lower relative molecular mass. So relative molecular mass, the particle will move slower. So nitrogen, but nitrogen is diffusing faster. So nitrogen is having a lower relative molecular mass, so it will move faster or diffuse faster. So use the term relative molecular mass, okay? Like some student use mass only, that is not the right term. Some student use molecular mass only. That is correct, but not the complete answer. So in exam, whenever you compare a rate of diffusion, you should always refer relative molecular mass, okay? Always use the term relative. Why it we called relative molecular mass? Because it's a mass of an atom compared with a 12th part of carbon 12 or a mass of a molecule compared with a carbon 12. So nitrogen gas has a lower relative molecular mass than chlorine, so it will relatively lighter or move or diffuse faster. Explain why nitrogen gas diffuse faster at a high temperature. So when we increase the temperature, what will happen? At high temperature, the particles will move faster. As the particles will move faster, they will have a greater kinetic energy. The next is question 4, part A. Chromium is a transition element, transition metal. Two difference in the physical properties. So this is a very common type of a question in which we have to compare a transition element with a group 1, alkali metals. Physical properties such as melting point, boiling point, density, texture, strength. These are the physical properties. So chromium is harder, sodium will be softer. Chromium is denser, and sodium will have a high melting point or a boiling point is there. For chromium, harder, denser, high melting point, high boiling point, high density compared to that of sodium. Then give two difference in the chemical properties of a chromium and a sodium. What is the difference in the chemical properties? So when you compare the chemical properties, you refer the oxidation number, you refer the reactivity, or you refer the catalytical property. So chromium, when we compare reactivity, it will be less reactive than sodium because alkali metals or group 1 are more reactive. Then when we talk about the catalytical activity, chromium can act as a catalyst, but sodium cannot act as a catalyst. And they have a variable oxidation state. So they will have a variable oxidation state. How do we know if something is chemical or physical? So how we know something is a chemical or physical properties are measurable properties in which no new substance form. Chemical properties are the properties in which a new substance will form. So whenever you refer a physical property, you will talk about the melting point, because when some substance melt, it will only physical change happen. Chemical, there is no change in the composition. Boiling point, density, the texture of the surface, hard, soft, these are the physical properties. But when you talk about the chemical properties, for chemical properties, you can compare the reactivity, you can compare the loss of electron or the gain of electron, because loss of electron and gain of electron, substance will chemically change. Or you can also talk about the catalytical activity. These are the chemical properties. Like when something chemically transformed during a change, we call chemical property. Like if I add a sodium metal to water, it will turn into sodium hydroxide and hydrogen. So sodium metal chemically changes. So I will say this is a chemical property. But when I melt the sodium and it turn into a molten sodium, it's a physical property, because sodium atom remains sodium. It's only physical changes happen or occur. The next in part B, chromium is used to electroplate steel object. So we have a chromium sulfate is there, chromium 3 sulfate. So chromium is plus 3, sulfate is there, SO4, and it is aqueous. So it contains hydrogen ion and a hydroxide ion. Give two reasons why steel objects are plated with a chromium. So what is the reason for electroplating? The main purpose, like if you want to something appear to be like good in surf, like in terms of that appearance, if we want it to be shiny or looks different, we can do that as well, electroplating. Or if you want to protect anything from reaction, we can also do electroplating. So to make them corrosion or scratch resistance good, or to make them look good, for that's these are the best points. So that the things will appear good. That is why we electroplate, or we want to protect them from corrosion or the surface scratch. Then we can also do electroplating. The formula of the chromium 3 ion. The formula of the chromium 3 ion is Cr3 plus. And the sulfate is SO4. Give a formula of the chromium 3 sulfate. So what is the formula of the chromium 3 sulfate? Chromium is there Cr, and it has a charge of 3 plus, and sulfate is SO4 with a charge 2 minus. So when the valencies are not same, we cross multiply. So when we cross multiply, it will be Cr2 SO4 in a bracket 3. So that is a chromium 3 sulfate. So the next is write an ionic equation for reaction at the negative electrode or a cathode. Sulfate, nitrate, and carbonate ion never moves. So sulfate, nitrate, and carbonate never move. So which ion? So we have the chromium ion is there, and the chromium, we want electroplating of a chromium, so chromium should move there. So as the chromium will move towards the cathode, chromium is 3 plus, it will take 3 electron and turn into chromium metal. So aqueous chromium, take 3 electron, turn into chromium solid. A colorless gas which relight the glowing splint is formed at the positive electrode. So this is a test for what? A colorless gas, relight the glowing splint, relight. So glowing state relight, which gas is this? This is the oxygen gas, O2. If it was a hydrogen, it will pop sound. Yeah, hydrogen is also colorless, give a pop sound with a lighted splint, not a glowing splint. The next is during electroplating, it is necessary to add more chromium 3 sulfate during the copper. Okay. During electroplating, it is necessary to add more chromium 3 sulfate, but during copper plating, so during a copper plating using a copper anode, it is not necessary to add more copper sulfate. Explain the difference. Because what will happen when we use a copper anode, like anode is made up of a copper, and here this is an object which we want to electroplate. So let's say this object we want to electroplate. And the salt is a copper sulfate salt, which contain a copper ion, it contain a sulfate ion, it contain hydrogen ion and hydroxide ion. So copper ion will move towards the cathode and a copper atom will go inside the solution as a copper ion. So why, but in case of a chromium, we have to add. Why? Because if you see this, anode was made up of lead. No, you did not solve. It's not from that.
You did it you did it by yourself. Means you questions.
No. That's a full paper. This is a full paper, but you have not solved. Look, in this question, during electroplating, it is necessary.
Sir, I'm not following your criticism. I'm just solving randomly from the book.
No, I give you a paper.
Yeah.
So solve.
Okay. They are using the books.
Close
That's
it.
another thing. That's
Okay.
I can't even open the book.
So you have, if you use a copper plating, in a copper plating, anode is made up of a copper, electrolyte is a copper ion. So when copper ion move towards the cathode, one of the copper atom will go inside the solution as a copper ion. That's why we don't have to add. But in chromium plating, what is happening? This is made up of a lead and we have a chromium 3 ion. So when the chromium 3 ion move, there's nothing to balance the chromium 3 ion. So, but during copper electrolysis, when one copper ion is going out from the electrolyte, another copper atom will turn into copper ion. So explain this difference, why in copper plating, we don't have to add copper sulfate, but in a chromium plating, we have to add. So what will happen in a copper plating? The copper ion move towards cathode is balanced by copper atom turned to copper ions in the electrolyte. So the copper atom turn into copper ion and move into the electrolyte. So when one is okay. You have 20 minutes almost.
36 minutes, man.
This question is about the extraction of iron. Iron is extracted from its ore hematite in the blast furnace. So describe the reaction involved in the extraction of iron and include one equation for a redox and one for acid base. So what actually happened in this titration, extraction of iron? So what will happen? The air from the bottom entered from the bottom, which mainly contain like it contain nitrogen, 78% nitrogen, 21% oxygen, and remaining other gases are there. But the active component of air is oxygen. And we add a coke first. So when we add the coke from the top, so carbon reacted with oxygen to give carbon dioxide. This reaction is exothermic, so the temperature of the furnace increases. So the temperature of the furnace increases as this reaction is exothermic. Then the carbon dioxide reacted with more carbon to produce a carbon monoxide. Carbon monoxide is a reducing agent. This carbon monoxide reacted with ore of the iron and it produced a iron metal and produced carbon dioxide. So iron is having a high density, so molten iron will be there at the bottom of this furnace. And for a neutralization, because the ore of iron contain an acidic impurity, which is silicon 4 oxide. So silicon 4 oxide reacted with a calcium oxide. Silicon 4 oxide is acidic, calcium oxide is a basic. So what it will form? It will form slag CaSiO3, which is a calcium silicate. So this is the overall